Hello everyone, how are you guys doing? I hope that you're doing well. So today I want to start talking about the principles of profit maximization. Let's begin. So we're going to start talking about principles of profit maximization for a monopolist. Remember the definition of a monopolist? The traditional definition is that there's a single firm that serves the entire market, and a slightly weaker definition of monopoly is a market which can have more than one players, but is a kind of a market which has a clear dominant player. There is one firm that kind of dominates the market. So for such firms, they have significant price making ability. These firms can choose their own prices and also their quantities. In this video recording, I want to analyze, we're going to analyze together how these firms make their decisions, or put it differently, how should they make their decisions. So a monopolist, when it's choosing its prices and quantities, it is facing the following problem. Well, it is basically facing a demand curve which is determined by the consumer's preferences. And the monopolist needs to ask himself or herself, what price do I want to charge? And also how much do I want to sell? Right? I need to choose both prices and quantities. And these two decisions are related, because they both depend on the demand function. So there's a trade-off between price and quantity, and this is because of the shape of the demand function. So remember, the demand function is downward sloping, and because of that, the monopolist cannot increase its price and quantities at the same time. Put it simply, the monopolists can do a high price and a low quantity. I can charge a high price, right, but sell in low amounts. Or I can lower the price substantially. I can do low price, but high quantity combination. So which of these pairs is better for me if I want to maximize my profits? So the answer to this question will depend on the specific circumstance of the firm. There isn't one universal answer to this. It depends on the firm's cost function as well as the revenue function that it's facing. In general terms, okay, so the answer to this question is determined by the marginal output rule. One just quick disclaimer, this is actually a purely mathematical, characterization of profit maximization. There isn't a whole lot economics actually behind it. This directly comes from optimization problem, which is like quite, mathematical a little bit. So we're not going to go that much into the technical details. That's not my goal. But I still want you to understand the idea, the economics behind this margin output rule at an intuitive level. So I'll try to explain the intuition behind it. So the margin output rule tells us, let's read it here, as long as the firm stays in the market. So always keep that in mind, okay? We're going to come back to this. So this output rule doesn't tell us the entry and exit condition for a firm. It tells us if the firm decides to stay in the market, then it can obtain the highest possible profits for it if it produces an output level where marginal cost is equal to margin revenue. Okay, so that's why it's called margin output rule. So what does it mean? Okay, let's try to understand this intuitive level, as I said before. Well, this rule also implies that if the firm is producing at an output level where margin revenue is not equal to marginal cost, then it's not optimizing its profits. Let's ask why. Let's begin with the simpler case. The first one, which is when marginal cost is greater than the margin revenue. A lot of people find generally this case, a little bit more straightforward and easier to understand. So let me begin with that. According to this rule, right, if you're producing at an output level where marginal cost is greater than margin revenue, then you're not optimizing. Let's think about it. Let's think about the context of aluminum producers. If you remember in the very first lecture, we had this supply function, right? We construct the supply curve for the aluminum producers. You're an aluminum producer. Suppose that you're producing 100 tons. And now the question for you, would it be actually more profitable for you to produce 101 ton instead of producing 100 tons? How would you answer that question? Well, to answer that question, so remember, profit maximization is always done by thinking on the margin. So you need to ask yourself, what is the marginal benefit and the marginal cost that I get from producing that additional 1 ton unit of aluminium? So I'm producing 110, so I look at that point, what would the margin revenue and what would the marginal cost? If the marginal cost is greater than the margin revenue, then I simply decide that producing that additional unit of output, right, on the margin basically reduces my profits. So therefore, it wouldn't be optimal for me to increase my output level by that 1 additional ton. So you can see that basically this is not optimal. What about the opposite case, right? According to this rule, if you're producing at an output level where it's the opposite case, when the margin revenue is greater than marginal cost, that's not optimal neither. So that might be a little bit more difficult, at first, may seem a bit more, puzzling to understand. You may think, well, for that additional unit, the marginal revenue, the benefit that I get, is clearly greater than the cost of it. So why wouldn't that be optimal? Well, of course, if the margin revenue is greater than the marginal cost for that additional ton, aluminium, additional ton of a unit of aluminium, you do want to increase your output level, but it's not optimal because if the margin revenue is much greater than the marginal cost, then maybe you don't want to increase your aluminium output level by only 1 ton, but many, many tons, right? So that's not why it's not optimal. So let me explain these ideas on a figure. I think by visualizing it, you can understand this intuition a bit in a more clear way. So we have a profit function here, and we plot it as a function of quantities. So first it makes me, what does it mean? In some sense here, I'm doing a gigantic scenario analysis. I ask my analyst, right? I say, well, please tell me what could be my profits, what would be my profits under different price quantity combinations. If I charge, for instance, a very high price and sell a low amount, a low Q, what will be my profits? And what will be my profits if I reduce the price and increase the quantities? And what will be my profits if I reduce the price even further and then sell even more? So basically, I asked the analyst, right, to draw me, to calculate the profits that I could earn under different price and quantity combinations. And then, to make it easy for me to process all that information, then they plot it on a figure, on a graph. So by looking at this, right, and for many firms, by the way, the profit function will have a shape something similar to this. By looking at this, you can actually immediately see that your total profits are maximized at that quantity level. That's Q star here, right? It is increasing here, up to here, and then if you continue to increase quantities beyond that point, then it starts decreasing. So this is where you want to stop in terms of the production. So and then the question becomes, what are the properties? What is special about that point? Why was it the optimum, quantity level? Well, that's the optimal quantity level because at that point, this is exactly the point where marginal revenue is equal to marginal cost. So why is that? Let me move to the next figure. It's the same profit function. Well, it's with slightly different shape, but it's just the same main idea. And here, I want to plot it also with margin revenue and marginal cost functions simultaneously. We can see both of them at the same time. So here I have profit function plotted as a function of quantity. And here I again have quantity here on the x-axis. But this time on the y-axis, I have marginal cost versus margin revenue, depending on what function that I plotted here. So I have two functions here. So the black one here reflects the marginal cost as a function of quantity. And the green one here is basically the margin revenue as a function of quantity. If you remember from the previous recording, let's just first quickly review what these basically functions tell us. Well, it looks like this is a firm that has a constant marginal cost. For us to apply the profit maximization principles, the marginal cost doesn't have to be constant. I could use any other shape. So this is just for simplicity. And the margin revenue, it is a downward sloping And if you remember, we discussed for margin revenue, well, it is generally downward sloping. Only in some special cases, maybe it is flat, but most of the other cases, it is downward sloping. And the idea here is that the margin revenue curve basically mimics the shape of the demand function. Because the demand is downward sloping, then the margin revenue will also have a similar shape as well. Okay, so now let's look at it. So in this area, right, for relatively lower levels of quantity, let's look at how these, profits, margin revenue, and marginal cost, they're all related to each other. So at initial relatively lower levels of quantity in this region, as you can see, the green line is always above the black line, which basically means that the margin revenue is always greater than marginal cost. Conceptually, what does it mean? For any point here, if you increase your output level quantity by one more unit, because margin revenue is always greater than marginal cost, it means that your profits will also increase, as you can see from this function here, right? Because for this region, margin revenue is always greater than marginal cost, it always increases. But it continues to increase up to this point, right? Initially, the wedge between the margin revenue and marginal cost is high. So even if you increase your output level by 1 unit, you get a large profit benefit. But as you continue to increase your quantities more and more, the difference between the margin revenue and marginal cost is shrinking. So much so that at some point it becomes zero. The margin revenue is exactly equal to margin revenue. If you continue to produce beyond that point, quantity point, what happens? Well, now look at it. Now the black line, now it is always higher than the green line. So this time the marginal cost starts dominating the margin revenue. Conceptually, what basically means that beyond that point, for each additional unit that you're producing, you start losing money. And because of that, because for each additional unit the profits you're losing, then the profits are basically starts going down as you started to increase quantity beyond that price point, beyond that quantity point. So you can see from here then, the last unit that you want to produce is the point where margin revenue is equal to marginal cost. This is the last unit, right? Because beyond this unit, then marginal cost starts dominating. And because this is the last unit that you want to produce, this point gives you the highest possible profits that you can obtain. So that's the idea behind profit maximization rule, which is called margin output rule. In some sense, the profit maximization algorithm works as follows. There are 2 steps. In the first step, you look at the relationship between the margin revenue and marginal cost, right? And that gives you the output level, which is basically what we did here, right? We had always quantity here. That gives you how much you want to produce. As an aluminum producer, in some sense, it basically tells you what should be the size of your factory. Do you want to be a very big player or a medium-sized player, for instance? Or for a particular type of aluminum product, right? How much do you want to supply to the market? It gives you the quantity. But as a producer, right, you don't go to the market and say, this is how much I want to sell. You have to attach a price to your product to attain your target sales volume. So which means that you need to basically find the price. This is how much you want to sell, ideally, right, to maximize your profits. We need to find out how much you should be charging your products to be able to sell that much Q star, your target sales volume. And to figure that out, then you need to look at the demand function. Because demand function, remember, tells you how much you can sell at any given price point. So you say, well, this is my target Q star, my quantity level. And if this is what I want to sell, how much should I charge? So then you look at basically the price point that it corresponds on the demand function. So if you charge P star, right, then you will be able to sell Q star. So the P star and Q star basically, and this is step number 2. So that combination gives you your optimal profit maximization. Final point here I want to discuss. Okay, so the monopolists did all these, analytical calculations and figure out what is its, optimal price. So at an intuitive level, you may think, well, the monopolist, right, because it's a monopoly power, well, it should probably be always charging a very high price, as high as possible, right? So that is true, but what monopolists can charge will actually depend on the consumer's preferences. Put it differently, a monopolist, rather a misbehaving monopolist, may have a strong incentive to charge really astronomical numbers. The only disciplining effect, unless there's some regulation in the market, the only force that can discipline a monopolist is the consumer's preferences. So why am I saying this? Okay, so if you continue with this analysis, right, you solve for the profit maximization, and then you will find that there is a relationship between markups and the price elasticity of demand. Let me first define the markups. Markups are defined as the difference between the price that the firm is charging minus MC, the marginal cost. Here we're dividing by price, because once we do that, so this ratio, which we generally represent in percentages, it is comparable across products. It is unitless, so it is comparable across products. So the percentage markups are inverse function, are inversely related to the price elasticity of demand. So why is that? Well, just think about it. Well, first of all, let me explain why it's the inverse. Well, remember the price elasticity of demand, the more inelastic demand curve is, E will be a smaller number, right? Less than 1, if you remember from my previous recordings. And therefore, this ratio will be greater. Right? So basically, the more inelastic the demand curve, this ratio larger, then the higher the markups. So why is that? Well, the reason for this is, just think about it at an intuitive level. If the demand side is extremely inelastic, then the monopolists will realize that, well, for instance, what would happen if I increase the price by, say, 50% or 200%? 300%. Actually, sometimes pharmaceutical companies do such things. The demand in that context is super inelastic. Then, of course, because the demand is so inelastic, they realize that even if they increase the price by, say, 200%, it will be the same quantities. So there's a room for increase their profits basically by charging much higher prices. An inelastic demand curve basically immediately reflects in a higher markup. The opposite is also true. If the demand side was, for instance, very elastic, then the firm, the monopolist, even for a monopolist, even for a pharmaceutical company, for instance, or as actually pharmaceuticals, is difficult to think about a product with an elastic demand curve, but a different type of monopolist for which the demand curve, for instance, happen to be more elastic. Then for such firm, even if it's like a monopoly, it's actually not going to be able to enjoy a high markup. Because if they increase the price range even 1%, because the demand is so elastic, the quantity is going to shrink substantially. So then therefore, they're not going to be able to, it's not going to be in their interest actually to increase the price, because they're losing a lot, from the quantity side. So so that's what I was saying in the beginning. So the only force, the monopolists, because it's a market power, have always a very strong incentive to charge higher prices and enjoy a high markup. The only thing that can discipline, meaning that it can put a force on monopolies not to charge extremely high prices, is basically the consumer's preferences. If the consumer demand is elastic, then the markups are going to be kept at a low level, even if it's a monopoly. All right. So if you want to see more discussion about how the pricing works in pharmaceutical companies, I would strongly recommend that you take a look at this documentary. It's a new form of cancer treatment apparently that is being implemented right now. And as you can imagine, that the demand for such cancer treatment is extremely inelastic. And you may want to take a look at how pharmaceuticals companies are basically pricing these new treatments. I thought you may find it interesting. The documentary is a little bit on the long side. It's almost like, I think, 45 minutes. But yeah, this is not required. It's only for the interested students. And if you have free time, yeah, I would strongly recommend take a look at it. Alright, that's all I want to talk about today. Thank you very much for watching. I hope you enjoyed this video. Bye.